Cotangent normally opens down from left to right. But if I have reflected that, now I need to be opening up from left to right. Okay? So just kind of envision if this graph were to extend, cotangent would do this sort of thing. Okay? We obviously don't have that much space, so all we get to graph is it's rising to 0. Versus on the left-hand side, imagine that it came from the left, and then once we hit 0, we can only see the rising above section. All right, so amplitude, we obviously do not have one. All right, my range still going to be negative infinity to infinity. All right, domain-wise, all real numbers except our very first asymptote is at 0, plus minus, and then it will end up being a whole 4 pi k before we see another asymptote, because notice that in this stretch of 2 pi, we can only see half of the cotangent wave. Plus this stretch of 2 pi, we see the other half of the cotangent wave. So 2 plus 2 is 4. It would be a whole 4 pi before we see another asymptote. Okay? All right, so now let's practice one where we put it all together. So -3 sine of theta plus pi plus 1. All right, the plus 1 is a vertical shift. So if we'd like, let's go ahead and add. That is where my new x-axis should be. The pen's dying. All right, the -3 means that we are going to have a reflection. The 3 itself means that we're going to have an amplitude change. So we are both changing our max and min while also reflecting. So we could even just come down here and add my new amplitude's 3. All right, our b value in front of theta is a 1, which is great because that does nothing to my period and nothing to my new tick marks. But if we go through that same process as before, sine normally has 2 pi divided by 1, that's still 2 pi. That's no different than normal. Then we would take my new period, divide by 4, so we're still going to have tick marks at every pi over 2. Again, that's just like before. All right, but notice in this case we do have a phase shift because we have a group. We have theta plus something in parentheses. All right, so out here to the side, if we were to set theta plus pi equal to 0 and solve, we would have a phase shift of negative pi. Now notice there's not a blank for you to write that, but it is very important that you recognize that your graph has been shifted, okay? Specifically to the left by 1 pi. So over here at negative pi, I'm going to add, kind of like we did yesterday, think of that as your new 0, 0. Okay? All right, so at this location, if that is kind of my 0, if you will, sine would normally start at 0. It will still start at 0. Let me pick a different color. All right. From there, sine would normally move up 1 and then back to the line. But if I have a -3, I now have to move down and 3 away from the line. So 1, 2, 3. All right. Back up to the line and then up 1, 2, 3 from the line. I know we ran out of space up there. That's okay. Back to the line, down 1, 2, 3 from the line, and then back up to the line. All right, and continue that pattern over here. Okay. All right, sketch. All right, our domain, still no different, negative infinity to positive infinity. Our range has gotten much larger. We're stretching all the way down from -2 up to +4, both included. Okay. All right, so I'll run through a few of these with you, and then I might leave a few to see kind of if you could do on your own and just show you what the final answers would be. All right, so we're not graphing these, but it just says complete the chart for all of the trig functions. Okay, so you will have a section on your quiz tomorrow that looks very similar to this table. All right, so if we look at number 1. All right, first question is, do we have an amplitude? Sine has an amplitude, obviously, and that new amplitude comes from multiplying by 4 in the front. All right, reflection, yes or no? In this case, no, because that 4 is not a negative 4. All right, for period, we need to look at B and see if it's changed. All right, in front of theta, my B value is 1. That is no different than before, so my period should still be 2 pi. All right, my period is 2 pi. I would divide that by 4 to get the new tick marks, which is pi over 2, which again is no different than before. Okay? We only have a phase shift if we have a set of parentheses, if we have a group with the theta. In this case, we do not have one, so there is no phase shift. And then vertical shift, yes, we have one of those, moving up 6. Okay? For the second one, all right, negative 3 cotangent of theta minus pi over 4. All right, amplitude. Please don't be tempted to say negative 3. While yes, there is a coefficient of 3 out front, cotangent has no amplitude because remember there are no maxes or mins, so my amplitude is none. Is it a reflection? Yes, because we have a negative coefficient out front. All right, your B value is a single 1. That's the same as it always is, but if you wanted to check it again, cotangent normally has a period of pi, and if I divide 1 by pi, pi by 1, that's still pi. All right, my new tick marks would come from taking pi and dividing by 2 for cotangent, which is still pi over 2. All right, my phase shift, I do have a set of parentheses, so I need to take theta minus pi over 4, solve for theta, which would give me a positive pi over 4. Vertical shift, do not have one, because there is no constant added or subtracted to the end or beginning. All right, for number 3, all right, this negative 2 out front, that's by itself, that's a vertical shift of down 2. All right, the negative in front of the sign indicates that it is a reflection, and the fact that it's a negative 6 means I do have a new amplitude of 6. Now remember, your amplitude is never negative, it's just the absolute value of the distance, so just 6. All right. In this case, we do have a new B. So my B is 2. Sine normally has a period of 2 pi. And if I divide that by 2, my new period is pi. All right. To get my new tick marks, we take the new period and we divide that by 4, which in our case is just pi over 4. All right, we also have a set of parentheses, which means we will have a phase shift. So over here to the side, if we set 2 theta plus 2 pi equal to 0 and solve for theta, we would end up moving 2 pi to the other side, and then we would have to divide by 2, which would give me negative pi. All right, for 4. We do have a value multiplied out front, but cosecant does not have an amplitude ever, so that's none. All right, there is no negative value out front, so not a reflection. My B value in this case is 3. Cosecant normally has a period of 2 pi. Divide that by 3 is 2 pi divided by 3. To get your new tick marks, we need to take the new period and we need to divide it by 4. if it helps to think about it this way, think that you're really taking 2 pi over 3 and you're multiplying it by 1 over 4, which would give me 2 pi over 12, which is really pi over 6. All right, we have a set of parentheses, so my phase shift would come from setting 3 theta minus pi equal to 0, which means we would have to add pi and divide by 3, which would give me positive pi over 3. We also have a vertical shift at the end by adding 7. All right, for number 5, we have no values out front and no negative out front, which means our amplitude is understood to be 1, no reflection. Do not say no amplitude for number 5 because cosine has an amplitude that's 1. There's just not a new amplitude. Okay? All right, our b value, 2/3. Period is normally 2 pi. Take 2 pi and divide it by 2/3, which would give me 3/4. If it's easier to think about it this way, you've got 2 basically times 3/2. I didn't do that right. So yes, 2, that would give me 3 pi. My bad. I looked ahead. I said something else. So take 2 pi, divide it by 2/3, which is really times 3/2, which would give me 3 pi. We have to take our new period and divide it by 4 to get our new tick marks. That's where I got 3 pi over 4. All right, our phase shift, again, comes from the parentheses, so out here to the side. If I were to set 2/3 theta plus pi equal to 0, first we would have to subtract pi, so it would be negative. And then we would have to divide by 2/3, or in other words, multiply by 3/2. So my new phase shift would be negative 3 pi over 2. That's a fun one. And then we have a negative 1 at the end, so a vertical shift down 1. All right, last 2. Negative out front, which means yes, a reflection for sine. Amplitude is always an understood 1. All right, my b value is 3. Period is normally 2 pi divided by b. So new period is 2 pi over 3. Take my period, 2 pi over 3, divide it by 4, which is really times 1/4. So that's the same as number 4. That's going to end up giving me pi over 6. Or I'm sorry, yes, pi over 6. All right, my phase shift comes from setting that equal to 0. But if I set 3 theta equal to 0, that's just 0. So no phase shift. Nothing really got added or subtracted. And then negative 3 is a vertical shift of 3 at the end. And our very last one, my chart's over on the next page. All right, so cosine, amplitude of 1, no reflection because there's no negative. All right, I'm going to drop this one down here. My b value is 4. My period is normally 2 pi. Divide that by 4 is going to give me pi over 2. To get my new tick marks, take my new period, divide that by 4, which is going to give me pi over 8. So very much condensed. All right, our phase shift, looking at my parentheses, if I set 4 theta minus pi over 2 equal to 0, first we would have to add our pi over 2, and then we would have to divide both sides by 4, or in other words, multiply by 1 over 4. So my phase shift is going to be a positive pi over 8. And then we have no constants added or subtracted, so no vertical shift. Okay, I know that was a lot, but I'm leaving document 10 for you to practice. So that looks almost identical to document 9. You've got a few less graphs. I would like for you to do this for homework tonight, and I